So this question is question 13c from the 2017 HSC Extension 1 paper. And in this question, we've got a golfer hitting a golf ball with an initial speed of v meters per second at an angle theta to the horizontal. And they hit it over a lake, and it must be at least 100 meters range, otherwise it falls in the lake. So basically, we're given these formulas for the x and y displacements, and we need to show that the horizontal range of the golf ball is v squared sine 2 theta on g. So to find that, well, we need to know at what point the golf ball will hit the ground again, okay? And that is when y equals 0 a second time. And so when we substitute y equals 0 into this equation here, we've got vt sine theta minus a half gt squared equals 0. And we'll tidy that up. And we've got t equals 2v sine theta on g. So that's going to happen at time 2v sine theta on g. And so what we want to know now is, well, what's the x value at time 2v sine theta on g? And if we substitute that into our x displacement equation, we've got vt cos theta, which is 2v squared sine theta cos theta on g. Now, if we look at that, that looks an awful lot like our double angle formula. And it's probably easier to not even remember the double angle formula, but instead to think of the two angles, the sum of two angles. And so we've got sine 2 theta, essentially, is 2 sine theta cos theta. And so x is v squared sine 2 theta on g. So now that we've got that, if we know that v squared is less than 100g, we can just substitute that in, right? And so we've got x is less than 100g times sine 2 theta on g. That being the case, since we know that sine 2 theta has got to be less than 1, then x has got to be less than 100, or 100 meters in this case, which means that it will land in the lake. So the next part of this question says that v squared equals 200g. And we also know that the horizontal range of the ball is 100 meters, at least 100 meters. And so we can substitute the 200g into our range formula, which we have as v squared sine 2 theta on g. V squared being 200g, we'll pop that in. And we've got 200 sine 2 theta is greater than or equal to 100, so sine 2 theta is greater than or equal to a half. Now, if you think about the way the sine curve looks, if you've got sine 2 theta is greater than or equal to a half, then sine theta is going to be a half when theta is pi on 6 or 5 pi on 6 and so on. And so we know that between those two angles, we're going to have values for sine 2 theta that are greater than or equal to a half. And so if we've got now pi on 6 is less than or equal to 2 theta, less than or equal to 5 pi on 6, then pi on 12 is less than or equal to theta is less than or equal to 5 pi on 12. So our next part says find the greatest height the ball can achieve. So we've got to remember that the angle is somewhere between pi on 12 and 5 pi on 12. And we know that the greatest height that is achieved happens right there in the middle of the trajectory. And so basically what we want to know is what is the height at half time, right? And if we recall that the time we discovered earlier was 2v sine theta on g, then half time is going to be at v sine theta on g. So now let's substitute that into our formula for the y displacement, and we've got vt sine theta minus a half gt squared, which is substituting in time v sine theta on g, we've got v squared sine squared theta on g minus half of that. And so it's going to be v squared sine squared theta on 2g. Now, if we think about the different values for sine squared theta that we could possibly get. And theta being anywhere between pi on 12 and 5 pi on 12, 5 pi on 12 is still less than half pi, right? So that's going to be the greatest possible value of sine theta that we're going to have. And so sine squared theta is going to be maximized when theta is 5 pi on 12. So here we have our greatest y value happening at v squared sine squared 5 pi on 12 all over 2g. And we'll recall that we've been told v squared is 200g, so we can pop that in. So if we tidy that up along the way, we'll have 100 sine squared 5 pi on 12, which comes out at about 93.3 meters.